Hey there everybody. The purpose of this video is to help you through p-value quiz number 1 from week 6's schedule page. So the trick with this one is the study's already been done. They've already collected data and given you a p-value. Your job is to make sure you know what the p-value means and which probability it applies to. So somewhere up above the... also let me take a time out here. If anybody had a problem with this quiz or the other quiz, make sure you look back at the homework. I know I don't require it to be turned in, but essentially I walked you through this kind of stuff in those homeworks. So whenever you need more resources, Google's always an option, but a more direct option probably is going to your homework. So the null hypothesis, we were checking out rates of learning disability in hypertensive kids and non-hypertensive kids. And the study thought there was a difference. You know, so their alternative hypothesis, their alternative is that the rate in the hypertensive kids is going to be different than the rate in the non-hypertensive kids. That's what they want to believe. But they're going to go into the study believing it's the same and then try to find a contradiction. If they can disprove the null at 95% confidence, that means you've supported the alternative. So what we're going to do is, these are the two probabilities we're going to figure out on the quiz, but keep in your mind at all points what that means. It means you've got a bell curve, or you can think of it as two bell curves. I think it probably makes the most sense to think of it as one bell curve for right now. And this bell curve is going to represent the differences in average between the two groups. So assuming that the two groups have arguably the same exact averages, the average difference should be 0. So there's your null curve, your null hypothesis curve. Your average difference should definitely be 0. So if we get data that lands close to here, they're arguably the same. If it moves too far to one side, one or the other has a significantly different one. We're only checking to see if they have the same rate versus different rates. This is a two-tailed test, but don't worry too much about that. Don't worry too much about that. I'm going to make it one-tailed because those are the ones we've been looking at in class so far. We'll talk more about two-tailed soon. So notice they got a p-value of 0.0002, which is 2/100%. That's pretty small. It's pretty small, all in all. So I'm going to draw that bad boy. Let's draw it somewhat to scale. And I'm going to put it all in one tail. I just rhymed like Dr. Seuss twice. My, wasn't that nice? These are the jokes, kids. So here's your p-value. Here's your p-value, 0.0002, which you're going to parrot back to me as less than 5%, which is correct. So right away, you've learned that less than 5% something's different, and that is something is different. Something is definitely different there. It's off of this curve, right? It's off of this curve completely. It looks like it's on some other curve that implies there's a difference in averages. Good. But what I wanted you to make sure that you could read this statement. What's the chance that we got data that implies that there is different rates if we're assuming that there was no difference in rates? So when you hear that out loud, read it to yourself or have me read it to you right now, you got data that implied the rates were different, but you were assuming that there was no difference. That's exactly what that number is. It's the chance you're on that curve. So the 0.0002, 2/100% is that probability. It's the measure of agreement between that null belief over there at 0 and where your data actually landed, which is over here at whatever the test statistic is. It doesn't matter, but it's over here at 0.0002. There's not much of an agreement at all. It's not much of an agreement at all. It doesn't seem to agree at all. What's the chance we should have gotten more similar data? Well, more similar would be moving more towards the 0, yes? And I even gave you a hint. I said it's the complement of the last one. So once you know that the first one's 2/100%, the other one has to be everything else that's there. So assuming the data were more similar, it should be moving closer to this, which is the data similar. So that's good right there. So there's your first two solutions there. The third, does it appear they have a different rate of learning disability? Well, yeah. That's what that tells you right there. It looks like it's too far away from that. So essentially, what we're saying is, we can't believe this. Formally, it's called rejecting the null hypothesis. That's what it's formally called. Rejecting the null hypothesis. But I say I believe the rates are different. Okay, that's more conversational. You don't want to tell your neighbor when you're trimming your hedges that you reject the null. You want to tell them it looks like the rate, the learning disability rates are different. What type of error could we have made? Always a type 1 when you have a small p-value. Define that error in context of the problem. I'm out of board. I guess I could write it here, but we'll just say it out loud. Your claim is that the two groups have different rates of learning disability. Okay, so that's your claim. We're going to say the rates of learning disability are different, comma, when in fact they're not. That's the chance of the error. The error is they might not be different, but you're saying they are. So it's the probability, okay, of a type 1 error is 5%. That's the last one right there. And the reason it's 5% is any p-value to the left, that magical 5% cutoff is somewhere over here. Anything to the left of that cutoff is going to trigger an unusual difference. It's going to trigger a difference. So since you landed over here, you're like, okay, something's up. So my claim, learning disability rates are different. You might be wrong. They might be exactly the same, but you said they're different. That's the way to be wrong, and that's the contextual reporting of a type 1 error. So there you go. There's quiz number 1. We'll get to quiz number 2 here in a minute.